My name is Olof Lindman. I'm a video R&D engineer working in the video core team at Sveriges Television. And joining me on stage is my esteemed colleague Finn Hermansson, who's a developer in the same team as me, which is called the video core team. Now, we are very excited to be here today to talk to you guys about Encore, which is our own in-house VOD transcoding solution that we have been developing on and off for more than 5 years at this point, and which we have been dog-fooding in production for more than 4 years. Now, here's what we got for you today. It's a presentation in 4 steps. We are going to start off with a short background, and I mean a short background, as to why we built Encore. Then we'll move on to the problem space. What sort of problems are Encore solving for us? And that we'll get into the more interesting part of this presentation and talk about the technical details. Finally, we'll do a future development sneak peek. What do we have in the pipeline? Now, I did mention that we're doing a short presentation of the background. I mean, normally when we do presentations like this, we iterate through the whole timeline, all the design choices. We're not doing that. We have a compressed version. Here we go. In 2018, we had an old commercial vendor solution that was reaching end of life. That wasn't very good. We were looking for alternatives. We needed something that gave us better control, better flexibility, and a lot better quality. We didn't want black boxes. We didn't want vendor lock-in. So we figured the best solution was to build something ourselves using FFmpeg and other open source tools. This turned into Encore, which 1 year later was doing all of the VOD transcoding at SVT for all the online platforms. And sometime after that, we open sourced it for anyone to use. And since then, it's been a pivotal part of our development and innovation for VOD. So, now that you guys know exactly why we did what we did, let's get into the interesting part of the presentation. So, in order for you guys to understand some of the architectural design choices that we made with Encore, it's good to know the context of the problems that we need to solve. Every streaming company have their own set of problems and thus their own challenges. Our problems can be described in a problem space with 3 categories. First, time is of the essence. It's of paramount importance that we transcode stuff on time, publish it on time. Secondly, we need that great quality and control. It has to be stunning visual quality while retaining low enough bitrate such that we can afford the distribution while having compatibility with all the devices that we are supposed to support as a public service company. And then finally, we need to be able to take this vast array of strange, weird inputs and change them into a proper output. Now, all of this has to be done within the confines of limited on-prem hardware. And we have our own in-house cloud at SVT, which is called Aurora, and it's great, but we are still using limited number of actual commodity servers. So if we deep dive into these a little bit, as you know, SVT is partly a news company. And as anyone who's ever worked in news knows, every second counts. And it's not only that we need to be able to transcode quickly, it's also that we need to be available all the time, because you never know when a new situation occurs. Now, SVT is also an entertainment company and a documentary company, a proper VOD streaming service. And it turns out that you need to publish regular programming on time as well, because otherwise you end up with a situation like this, where it becomes a national news story that SVT was 20 minutes late at publishing the first episode of Homeland. It turns out that the trust in our brand and what the audience expectation of us is high enough that we need to publish everything on time. And if you look at this from a concurrency point of view, you quickly realize that, well, all of the videos you receive might not be of the same priority, and you always need to be able to transcode the high priority stuff. If we move on to the other category of high quality and high control, when I talk in this industry, most people know what video quality is. They have a grasp of it, but the definition tends to differ. What we mean is the subjectively perceived visual quality of any given piece of playing video. Now, the key words here are subjectively and playing. Frame-by-frame comparisons are great, but they do not convey the experience of a viewer. Similarly, the industry is filled with people who will showcase the superiority of their product by objective metrics, and we just tend to think of them as a good first approximation. Maybe they're great for finding particular errors or see trends in large volumes of video, but they do not convey the way a viewer experiences the content. Now, you can't talk about something like video quality in streaming without mentioning compression. And in the regular triangle of high quality, more compression, and lower complexity, we have traditionally chosen to have the two former. But whatever solution we have needs to be able to do both. Likewise, SVT has one of Northern Europe's largest archives of media content, reaching back almost 100 years. We need to be able to take whatever's in that archive and handle it, okay? There's everything from house formats that you would know, to older house formats that some of you might know, to deprecated media formats. You need to know if you're deinterlacing, what kind of temporal units are there, how many audio streams are there, how many tracks do they have, what channel configuration are they in? Are you dealing with anamorphic pictures? What kind of color coding is that? And that moves on to technical parts such as scaling, color coding, aspect ratios, cropping and padding. Whatever the input is, the solution we use needs to be able to convert it properly. This goes for accessibility as well, because our audience have come to rely on particular accessibility features such as tydligare tal or uppläst undertext, which require specific audio handling. And if we take this control aspect and marry it to the previous quality aspect, we end up we're at the point where we need to be able to properly tune the way we transcode video. Because at SVT, we use something called genre-based encoding, and we need to know exactly, or at least to the best of our possibility, how we do that transcoding. This is where software such as X264 and X265 come in and are great. But, again, this is done on limited hardware. We have 8 servers on-prem doing all of this. And some of you might think that, okay, 8 commodity hardware servers running on CPU, that could be a lot or very little, depending on the volume of your content. So the other day, we pulled some statistics, looking back 2.5 years to see, all right, how much video do we process through our pipeline? It turns out that we do about 1 million videos in the last 2.5 years. That's about 1,100 a day. And if you do the sum total duration of the source content, that's 14 years. So in 2.5 years, we have transcoded 14 years worth of online video in various formats, and it's been on time, at least mostly, and it's also been prioritized correctly. Because this solution works for VOD, news clips, and quite recently also for broadcasting. Looking back at the summary then of this problem space, we need a solution that is able to do proper control and quality in a timely manner on limited hardware. When we look at the market, we're able to find solutions that can do one of these things really, really well. We might even find a solution that can do 2 of them really well. It turns out that, well, if you have a solution, you might be able to scale it in the cloud to reach the amount of control and do it on time, but we can't do that. And you might have a bunch of black boxes filled with GPUs. They'll give you the time you need, but then you won't have the control. The only solution that we have found over the years that adequately solves our problem space is Encore. Now, you guys might be wondering how, and that is what my colleague Finn will tell you now.
Okay, thank you, Olof. Before I go into the details on how Encore works, I would like to explain in brief its place in our systems. Our team is responsible for a collection of applications that we call core systems, and which purpose is to automatically transcode, package, deploy, and publish videos on time. Now, this is a simplified view of the main applications, where requester checks the upcoming 2 weeks of the Tableau for programs with an approved delivery in the MUM. If it finds a program that hasn't been transcoded yet, it will instruct the next app transcoder to start a job in Encore. A transcoder will choose a transcoding profile depending on the type of content, and Encore will transcode a bitrate ladder of files that are stored in our own archive called Stash. The files are packaged for HLS and Dash by packager, deployed to CDNs by deployer, and finally, we publish the URLs together with some metadata to a database. And for programs, this flow is completely automatic, but for news clips that don't have a Tableau slot, the process is triggered manually by user in the MUM. So the transcoding flow is an iterative process here, where we make sure that a viewable version of the content is available as soon as possible. So, for example, if this Homeland episode was delivered late, we start by transcoding and publishing using an AVC profile that is optimized for speed. Then we re-encode using another AVC profile that is slower, but is optimized for quality and compression. And finally, we transcode using a much slower HEVC profile. We package those files together with the AVC files from the previous step and republish. So, what is Encore? It's a Spring Boot application written in Kotlin. It's platform agnostic. We run it on Kubernetes, but you could probably run it anywhere as long as the runtime requirements are met. And those are Java runtime, the FFmpeg and media info binaries, and access to a Redis database. So this is an overview of the internal workflow of Encore. I will go into the details of the steps next, but in short, you create a job in Encore, it's put in a work queue, picked up from the queue, and then we run some FFmpeg commands producing output files. So in the first step, our app transcoder creates a job in Encore using a REST call. Here we specify a profile and where to put the output files and how to name them. And we can provide a callback URI if we want to be notified of progress during transcode. We set a priority in the queue. And together with the location of the input file, we can provide some decoding instructions in case of corrupt or missing metadata in the source file. We can also tell Encore to apply cropping, padding, or to transcode just a part of the file. Then this job is stored in the Redis, and next it's put in a work queue. The work queue is a list of small JSON objects referencing jobs, and it's sorted by priority and date. Okay. So at first, we started out with having just one queue, but it soon became apparent that all the Encore instances could be occupied with transcoding low priority jobs when a high priority job was in queued. So for example, if Homeland again was delivered late, it could, in worst case, wait for hours on the queue before even we enqueued it with the highest priority. So our solution to this is to have a configurable amount of queues, and we used 3. A high priority queue, a medium priority queue, and a low priority queue. And every Encore instance will run as many threads as there are queues, where, in our case, thread number 1 will pull only the high priority queue. And thread number 2 will first pull the high priority queue, and if that is empty, it will pull the medium priority queue. And thread number 3 will pull in order the high priority queue, the medium priority queue, and if they are empty, the low priority queue. So, in this way, a high priority job cannot be blocked by long-running, low priority jobs. So, now we're in the stage where we have picked up a job from the queue. Encore will run some analysis on the source file and read a profile with output definitions, and that data, together with some special instructions in the job, is used to generate an FFmpeg command to produce all the outputs at once. And the FFmpeg command starts with a filter graph that is split into video and sound. And for video, we start by deinterlacing if the source is interlaced. And if the source is anamorphic, we scale to square pixels using the display aspect ratio hint of the job. We can also add a logo, subtitles, apply cropping or padding here. Then the video filter graph is split into the individual outputs where we apply scaling. For sound, if the source has mono audio streams, then we use the channel layout hint in the job to drop any unused streams and join the remaining ones into one stream. Then we split this filter graph into the outputs where we apply downmixing using presets. And at the end, we add encoding parameters from the profile for each output. So this is an example of an FFmpeg command for the first pass of a 2-pass transcode. And as you can see, it's quite long. And the second pass is much longer because that one also includes sound and images. Okay, so now we run the command while monitoring the progress, and we notify our app transcoder using the callback URI from the job. And when we're done, we run some analysis on the output files, store the result in the job, which is accessible via REST, and we're done. Encore can now pull the queue for the next job. So this is where we are today with Encore. Next, I would like to talk about an upcoming feature that we've been working on. It's a project we call Encore Instant, where we're really pushing the limits of transcoding speeds. First, I would like to recap the numbers here. Currently, with our fastest transcoding profile, Express, it takes like 40 minutes to transcode 1 hour source video. And to that, we'll have to add 10 minutes for packaging and uploading to CDNs. So that means if, again, with HomeLens as an example here, if it's delivered less than 50 minutes in advance, we have no chance of publishing it on time. Okay. And another use case for high-speed transcodes would be when there's something wrong with the published video. For example, a face wasn't blurred in a sensitive interview, and we need to get a new version out there quickly. So the idea is to transcode segments of the source file in parallel across the cluster of servers. Now, this idea isn't unique, but it's a nice feature to have in Encore. So we start by instructing Encore to transcode in segments of a certain length in seconds. And Encore then runs an analysis of the source file to determine how many segments are needed. And we'll put each segment on the work queue. Now, this instance of Encore will take the role as a coordinator for the job. So, as Olof said, at SVT, we run our own Kubernetes cloud called Aurora, and we use a technology called KEDA, which is an acronym for Kubernetes Event-Driven Autoscaler. Now, KEDA is triggered when the work queue reaches a certain length and will spawn as many Encore workers needed to complete the queue. So when an Encore worker starts up, it polls the queue, and depending on the segment number, it will seek to the correct position of the source file and transcode one segment into a complete bitrate ladder. And this is done in parallel with many other Encore workers. And when it has completed a segment, it will signal the coordinator using a Redis message channel and then shut down. And when the coordinator has received completion messages for all the segments, it will complete the job by stitching the segments back together into whole files and complete the job. So in this way, we can transcode 1 hour source video that is 80 gigabytes in size in less than 2 minutes, straight from the archive, and while achieving actually better quality than our current Express profile.
Thank you so much, Finn. Right, I'll wrap this up by saying a few things. Although we think that Encore is fantastic, and it's been glorious to work on that for so many years, on and off, there are some pitfalls if you decide to do your own transcoding solution. And this is actually important to mention, especially if you're working with open source solutions. Because there is a certain requirement on the institutional knowledge of your company or organization. It also means that you're more dependent than ever on the skills of your personnel. Now, we've taken this risk for several years and reaped the benefits. Because in conclusion, Encore gave us the control and flexibility that we so sorely needed. And Encore has improved the visual quality of our VOD content immensely. Now, Encore has also allowed us to do the sort of innovation that we really need and help us facilitate development by being able to integrate in our systems. Now, for you guys, I mean, Encore is free, it is open source. The only real cost to it is the time spent by the developer working on it. And with those words, we would like to thank you for listening and take our leave. Thanks a lot.
Thank you.